Okay, let's keep going to record the second half for the rest of the problem of the chapter 8. So it mentioned the diagonal of the wxyz meet at A. Okay, w, x, y, and z diagonal meet at A. So we want to prove that by connecting the incenter. So what's the incenter? The incenter is the perpendicular of the angle it's the intersection of the angle bisector, right? So now we can see, okay, so because this angle bisector equals to this angle bisector, these two angles are vertical, right? So theta, phi, and phi, right? So this is phi, theta, theta. So we know that 2 theta plus 2 phi is equal to 180. So theta minus phi is 90 degrees. Okay, so it means theta plus phi is 90 degrees. They are perpendicular each other, right? And so if this is the I1, I2, I3, I4, I2, I3, I4, right? So the I2, I4 is the diagonal, right? And I1, I3 is another diagonal, right? We already proved they are perpendicular, right? So they have the perpendicular diagonals. Then next, so the E is a rectangle, the EFGH. EFGH, so it's 12, and this is 192, so that means this size is 16, and the EGJI, EG is this, and such that H is on the JI is a parallelogram. So parallelogram means these two lines are parallel. Okay, these two lines are parallel. So the connection of here is this triangle. Okay, so it just asks you what is the area of the parallelogram, right? EGJI. Okay, so you can see the EHG is half of the rectangle EFGH, right? And the EHG is also half of the parallelogram of the EGJI. Okay, so that's why you know these two are equal, right? So it's 192. So next is we have a rectangle ABCD. We have rectangle of the ABCD. Okay, and then AB is 8, AD BC is 9, that means AD is also 9, and we have the BH is equal to the 6, that's the H. Then we can connect the AH, and we have the E is the 4, so DE is the 4, E is the 4 and 5. The line EC will intersect with the AH at G. And we will do the GF is here. Okay, so we want to find the length of the GF. Okay, so in order to find the length of the GF, we need to find some similarities, right? So we see the first similarity is the GEF, right? Similar to the triangle, the CED, and for this one we know it's 4, we know it's 8, right? So what we want to solve is, once we solve the FD, then we can solve this problem, right? Okay, so let's try to see the other thing. So we want to solve the FD over the DE is also the GC over the CE is also the CH over the AE, right? So this is the 3 over 5. That means the CG is 3 to 5 of the CE, right? So it means this is 3 pieces, this 2 pieces. So let's say this is the 3T, this is the 2T, right? Then we can see the FD, right? So this is the 2 and over 3, this is the 4, right? So 2 piece is 4, so 3 piece will be 6. Now we can solve the bitriangle of the CED, similar to triangle of the GEF, right? So now you can see the FG over the 8 will equal to the 10 over the 4, right? Now you can solve the FG is equal to 20. Next, so we have a trapezoid ABCD. A equals, so okay, so it's like this. So if A equals D equal 45, okay, A, B, C, D, that means it's an isosceles trapezoid, 45 and 45. And then the B is 135, C is 135. If AB is 6 and the area of ABCD is 30, find the BC. Okay, so let's see it. This one and this one, right? So this is the 6, this is the 6. So you know the height is 6 over root 2, 6 over root 2, 6 over root 2. Then you know this is the x, right? So this is the 30. So we know the half of the x plus the 12 over root 2, right? That's this times the 6 over root 2 is equal to 30. Then we can solve equation, right? So this is the 5. So 10 is, so 2x plus 12 over root 2 is equal to 10 root 2. Then we can see is the x plus the 6 over root 2 is the 5 root 2. Then we can solve it is the 6 root 2, right? 3 root 2, so x equal 2 root 2. So the next is a circle is drawn through the vertices of the, okay. So normally we draw a circle first. If circle is hard to draw, then a square is inscribed in this circle, okay. So now we have the A, B, C, D inscribed in the circle, and the point X is on the minor arc of the C, AB. Then we know the XAB is equal to 1 and XCD is equal to 93. So what is the XAD plus XBC? Let's assume this is the A, right? So now you can see what happens here. So let's length the height. So here is the H, here is the A, right? So what we find is the half of the A times the H is equal to 1, and the half of the A times the A plus H is equal to the 993, right? So we are going to solve what is the ADX. So we can see the XAD is equal to half of the A times, let's see, this length is P, this length is A minus P, right? So it's P, and XBC is half of the A times the A minus P. So these two add together will be half of the A times A is half of the A square. So we want to, from the 1 and 2, to solve half of the square, right? So 2 minus 1 is half of the A square is 992. Now you know these two together is 992. So this one, the length indicate on the rectangle. Okay, so we can see there is a 5. There we can see there is a 5 and 5. So here is the, it's based, this is drawn based on symmetry of this O. This is the center of the rectangle. So here you can see it's 5 and 5, 9 and 9. Okay, the other thing is another line passing through this, so you have symmetry of 2 and 2 and 6 and 6. Okay, so if we draw all these two, now let's see how we can derive it. So let's see the so we want to calculate the shade area, right? Let's cutting the shade area into the two different pieces. Okay, now let's see what happens here. Okay, so you can see that we always want to relate it with each piece with the area of the rectangle. Okay, let's see the area of the rectangle. Okay, is equal to the K, right? So you can see this triangle, right? this is half of the k. This red triangle is k o is a quarter of the k, right? So the triangle of this is 14, right? Is a quarter of the k. So you can see the one piece, the piece 1, right? The piece 1 is 9 over 14, right? And times the 1 k over 4. And we can see the piece 2, right? The piece 2 will be this triangle. So you can see the triangle this, okay, is also a quarter of the k, right? That's 8. This is the 2. So this is also a quarter of the k, right? And this is the 2 over the 8, right? So the 2 is equal to the 2 over 8 times the quarter of the k. So now we have this part is equal to, this part is 32 over 2k is 1 over 16k. Okay, now we need to calculate the 1 plus the 2 is equal to 9 over 56 plus 1 over the 16 times the k, right? K is simple. K is 8 times 14. 9 over 56 plus 1 over 16 times 8 plus 14 times 14. So the answer is 25. Next. So we have a rectangle of ABCD. We have the PA and the PB. PA and the PB is equal to the 2 and the 3, and the PC is equal to the 10. We want to find the PD, right? So we need to parameterize it. Normally when we parameterize it, we want to starting from the side length, right? So here you can see this is the X, this is the Y, this is the Y, this is the X, then this is the U and the W, and this one is W and the U, right? So we can parameterize all this because you can see they are related with each other. So we can first, when we have the x squared plus the w squared equals 4. Second one, we have the y squared plus the w squared equals 9. Third one, we have the u squared plus the y squared equals 100. The goal is asking us what is the x squared plus the u squared, right? 1, 2, 3. So we want to have the x squared and the u squared, and we want to take out the y and w, right? So you can see this one equals to 1 plus 3 minus 2, right? So now you can see 4 plus 100 minus 9 is equal to the 95. So now you can see the PD is square root of the x squared plus u squared is root of 95. Okay, so the last one. We have a trapezoid ABCD. A, B, CD. Then AB is 6, BC is 7, then CD is 8, and this one is 17. So the side length, and if they are extend to intersect at the E, right? So we want to prove E is 90 degrees. Okay, so you can see the BD, the triangle BEC, right? Because they are parallel, is similar to triangle AEC. So the ratio of the BE over AB will equal to the BC over the AD minus BC is 7 over 10. Okay, so this one means the BE is 7 over 10 times 6. The EC is 7 over 10 times 8, right? Now let's see, we add the AE is the 6 plus 7 over 10 times 6, so it's over 17 over 10 times the 6. Then the BE will be the 17 over 10 times the 8. Then let's prove the AE square plus the BE square. Okay, let's say it's the 17 square times 1 over 10 of the square, then 6 square plus 8 square, right? So this one together is 1, so it's 17 square is equal to AD square. So that's why we can prove the angle AED is equal to 90 degrees Pythagorean, right? So yes, and that's it for this chapter. Thank you.